Hi everyone, welcome to my channel. I am Dr. Shivas here. So in this video, I will explain how to identify heteroscedasticity in dataset in SPSS. Heteroscedasticity occurs when the variance of regression residuals is not constant across different levels of the predicted value. So it can produce unreliable standard errors, confidence intervals, and significant stress. So we have data. This one, ethical leadership is independent variable and green creativity is dependent variable. So in this case, if the residuals are randomly distributed around 0 with a roughly equal spread, the assumption of homoscedasticity is satisfied. If the residual form a funnel, cone, curve, or another systematic pattern, heteroscedasticity may be present. So a random rectangular pattern indicates constant variance, while an uneven or patterned spread indicates a possible violation. So for this purpose, we do the scatter plot and go to graph, chart builder, select scatter plot, simple scatter plot, put and drop here, and then we put the green creativity as this is outcome variable on y-axis and ethical leadership on x-axis. And now click on OK. So scatter plot shows that there is approximately a positive linear relationship between the ethical leadership and green creativity, with no obvious curvature or extreme outliers. However, some clustering is visible at the maximum green creativity score. Heteroscedasticity can't be determined for this chart because this is just we need to see the pattern between green creativity and ethical leadership. So next process we see the heteroscedasticity assumption in linear regression analysis. So go back to our data and then click on analyze and go to regression and linear regression. So ethical leadership is our independent variable and green creativity is our dependent variable. We need to click on statistics and we see here we only need collinearity diagnostics, then click on continue. Plots, we need to put standardized residual, RESID residual, standardized residual on y-axis and residual predicted value on x-axis. Then we also need histogram and normal probability plot. Then click on continue. We also don't need any other value because we are doing heteroscedasticity assumption, and then click on OK. So these are the results here. So first we need to see the histogram. Okay, histogram is not approximately bell-shaped because strong concentration of 0 is very important and a long tail extending toward the negative side as well. So you can also see the most residuals below -3. At least one residual close to 0, -5, this one. So it means this residual close to -5. So because in case of the value of residuals should be between -3 to 3. Therefore, residuals appear negatively skewed and contain potential extreme outliers. Okay, so we also see the next normal PP plot of regression standardized residual, and the points show a systematic curved pattern and don't remain close to the reference line. This is a diagonal reference line. So it means the residual versus predicted scatter plot doesn't show an uneven rectangular cloud around 0. So it means the all points are far away from the diagonal reference line. So it means the residual spread is wider in some areas and narrow in others. You can see wider and narrow. So there is also a downward triangular pattern with several large negative residual concentrated around the middle predicted values. You can see minus sign line. Okay, so we also see the most important to check the assumption of heteroscedasticity is scatterplot through linear regression. So standardized residual and standardized predicted value. And you can see here the residual scatter plot contains a visible systematic pattern instead of completely random scattering. The linearity assumption may also be violated, or the regression model may be missing an important nonlinear component because this is not a linear scattering. So in this way, we actually use the nonlinear regression analysis. You can also see several standardized residual are below minus. So you can see here, because the residual value should be between -3 to +3. So that's why you can see here the most of the values, almost we can see some values are below -3. This one, because -3, all values are below -3. These dots show that below -3. And you can also see some are extreme below -4. So these are the extreme outliers. Because we use the standardized residual formula as the value of residuals should be between -3 to +3. So you can see there are many points values are below -3. So because these are the extreme outliers. So there is a potential influential cases, and we diagnosed that there is a violation of heteroscedasticity. So in this way, we found the heteroscedasticity of data. If you find my video helpful, please subscribe to my channel and press the bell icon.